Question 5, here we go. We'll insert a calculator page and we'll type in the function exactly as it's given to us. F open brackets x. To get the defined is equal to, press Control Template. And we're actually going to press the template key and pull up the piecewise function template, which is that one. And we'll just tell it it's only got one piecewise function. So we'll just have to type in the 1 bit, which it's defined for, press Control Divide and do 3/4. And then type in your open brackets x squared plus 1. And after the comma, we'll type in 0, press Control equals to get less than or equal to x, and press Control equals to get less than or equal to 1, and our function is defined. Now to just check that this is valid, we should do the integral of this over all values, and it should equal 1. So again, if I press Templates button and choose the definite integral, I'll just go from, well, I can go from minus infinity to infinity, but I can see that this function is only defined between 0 and 1. If I press the var key, it'll pull up f for me, and I can just do this. So this should give me the value of 1, and it does. Okay, so to get the expectation, what I need to do is just precede that with an x, and I get 0.5625, and I'm going to call that m for mean. So m is defined as being equal to that expression there. I'm going to go ahead and work out the integral, but this time with an x squared in there to get the expectation of x squared, and it's that. And therefore the standard deviation, which I'll just call s here, should be the expectation of x squared take away the mean squared, and I get 0.83594. So I've got my mean and I've got my standard deviation, and those are the two values on the screen. And for part B, we're being asked to work out the probability between. Well, effectively that is saying within one standard deviation of the mean. So if I can just go back up, get my expression and change the limits here. So I'm going to do one standard deviation less than the mean and one standard deviation greater than the mean, and I get the value of 0.165. And the question is done.